Professor Betti has an extensive list of publications on income inequality and concentration measures. So it's an honor for us that he has accepted our invitation. And just to give news concerning his publication, he has recently published a book with Routledge Publishing House, whose title is Advances on Income Inequality and Concentration Measures, which is co-authored by Professor Achille Leni. Thank you, Gianni, for accepting our invitation.
But I bring his apologies because he had problems, really family problems. So I'm going to give his presentation, and also in the afternoon I will show some results based on surveys in Europe. I'm going to talk about one particularly FTSE set approach. There could be many. This is one of the many. We, of course, believe very much in this approach, totally FTSE and relative, for estimating monetary and multidimensional poverty. Of course, this does want to be an alternative approach to the traditional one, but could be used as a complement, so a complementary approach. Just to make some to refer to the literature, this model approach was proposed by Bruno Kelly and Achille Leni in 1995 in Economic Notes, and after that there were a series of papers published in the International Journal of Metron. So Kelly 95, Kelly and myself in 99, and recently Betti, Kelly and Cambini 2004. I have brought with me some of these papers, so they are available for everybody, but in the internet you can find the website of Metron, and it is possible to download those papers. But moreover, this method has been officially adopted in two European projects. The first was in the second report on income poverty and social exclusion. I have here the report officially published by Eurostat. And the second was the report on regional poverty published by the European Commission in 2003. Here again we have the report. Both of them could be downloaded by the website of Eurostat, the European Statistical Office, and by the European Commission website. So before we were talking about, how to explain to policymakers, this theory, how to use, I have to say that it's really difficult, sometimes it's very difficult to explain. But at least we have tried to measure, so to use these measures, these FTSE measure for poverty and social exclusion. I don't know if policymakers will be able to use very much these measures, but at least we try to invest on it, and I think this is important. So the aims of this presentation are essentially three. First of all, try to develop a systematic approach to the extension of the conventional classification into poor and non-poor. So the CRISP definition explained very well by Professor Shorrocks before, and this by using a FTSE set theory. The second point will be try to introduce a multidimensional approach. So see how FTSE set theory could be used. So this multidimensional approach based on a set of supplementary variables, and we will see how it's possible to combine. So try to find rules of manipulations to combine, for instance, the FTSE monetary approach with the so-called FTSE supplementary, and in particular the diverse dimensions that we can find, we can discover using many other supplementary variables. And moreover, try to develop a dynamic model estimating correctly the mobility of individuals. Because we know that in the traditional approach, when we just divide the population into poor and non-poor, and we follow these individuals in the years, maybe with a panel survey, we know that the probability or the propensity of a person or a family who is very near the poverty line to cross the line, so what we call transient or transitory poverty, is really overestimated in the traditional approach. And the chronic or permanent poverty sometimes is underestimated. And from a policy point of view, for policymakers, policies are completely different in order to combat permanent poverty or transient poverty. So that's why it is very important to me try to correctly estimate poverty dynamics. And we have proposed something that could be of interest, also in order to complement what we get by the traditional approach. Of course, Professor Shorrocks has already introduced these concepts. Poverty is, in our opinion, a fuzzy set. So not only a discrete attribute, so a crisp definition in terms of presence or absence, is rather a vague predicate that manifests itself with different shades and degrees. So we really believe that poverty is a degree. And from these we try to construct an appropriate membership function. So we really want to distinguish between people who are just below the poverty line and people who are really poor, surely poor, and people that are just above the poverty line. And those people probably are very similar, and their characteristics are very similar of people that are just €1 or $1 below the poverty line. And in this methodology, we think that there are two very important steps. The first step is just to define a membership function. So a quantitative specification of a propensity to poverty, a degree to poverty, and of course a deprivation, social exclusion, when we take into account other supplementary variables. And we distinguish between, poverty, FTSE income poverty, and we term as FM, FTSE monetary. Monetary because sometimes we can also use consumption expenditure, not only income. It depends on the information that we have in the survey. And supplementary variables or resources we call FS, FTSE supplementary. This is the first step. And in this step, in fact, FTSE set theory is not involved very much, because it is involved only in the concept that poverty is not a crisp set, but it is a FTSE set. FTSE set theory enters very much in what we call rules of manipulation. So, when we observe monetary poverty and supplementary poverty, and in particular many different dimensions of poverty, how do we combine together? We are interested, as we have seen before, if a person is poor in every one of these dimensions. So we are talking about intersections, or in only one of these. So we are going to talk about of union, and so on. We can define complements, aggregation of the sets, and so on. So from this point of view, we can use very much the FTSE set theory, and we are going to present a methodology that could be one among other methodologies. Let's start with the first, so the so-called fuzzy monetary. Instead of defining a function which is 1 for people above the poverty, below the poverty line, and 0 for people above the poverty line, Kelly 95 just proposed to define a membership function which is simply 1 minus the cumulative distribution function. I show this graph. So here we have the cumulative distribution function, and 1 minus is exactly this value. So we give a very, very high membership function for poor people, or surely poor people, and a very small value for rich people. But for instance, if the poverty line were here, we give a very, very similar membership function to people that are just below or just above the poverty line. Of course, this method has a big drawback. The mean of this function is always 0.5. So we cannot compare, aggregate fuzzy poverty in Brazil, in Italy, in UK is always 0.5. So, and another problem, how do we compare these with a traditional approach? In the traditional approach, you may have 20% of poor people, and you have a mean of a fuzzy monetary poverty of 0.5. You cannot compare. You only can have a value at individual level, but could be not so useful. So later, it was proposed to link this membership function to the percentage of poor people according to the traditional approach. So for instance, just introduce an alpha value in order to lower this function. In this way, you still give a big weight, so a big membership function to poor people, and a much smaller value to rich people. In this way, you can calculate alpha so that the mean, mean of this function is exactly equal to, for instance, the headcount ratio. So the percentage of poor people according to the traditional approach. In this way, you can make some comparisons. Well, at national level, the percentage is the same. But if you make some disaggregation at regional level, or male-female, or different household size, or different groups of people in the population, you may see differences. Of course, the interpretation of this alpha is, from a statistical or economic point of view, is almost nothing, doesn't have any interpretation. So, later on, as this function could be interpreted as the percentage of individuals richer than the person concerned, later on in another paper it was proposed to consider not the percentage of individual, but the percentage of income received by individual richer than the person concerned. In this way, of course, we give even more weight, so more degree, a higher membership function to surely poor people. As we can see in the well-known Lorentz curve, if we have a certain person who is at this point of the distribution, this is just the percentage of people richer than the person, but the percentage of income received by those individuals, of course, is higher once we have ordered it. And but again, also this other measure, the alpha in this other measure did not have an economic interpretation. So recently, we have combined the two, putting together, the percentage of individual richer and the percentage of income, and using the same alpha. But now this alpha has an economic interpretation, because this is just a transformation. The mean of this membership function is just a transformation of the generalized Gini. So, of course, it is a sort of inequality measure, but in fact it was intended to be, because this was born as totally fuzzy and relative. So it's really a totally relative approach. And in fact, inequality could be seen as this fact. So in this way, we construct in a more or less arbitrary way a membership function, but we try to give also an economic interpretation. And in this way, surely poor individuals get a value very, very close to 1. By empirical analysis, we can see that values of people that are well below the poverty line have a score, a membership function like 0.97, 98, 99, you know. So they could be considered surely poor. And people that are just above the poverty line, maybe some 1,000 euro more per year, they receive a value very close to 0. The second part is try to construct a membership function using supplementary variables. So we have in every country, in most surveys, we have a lot of information, and we may use this information for constructing one indicator or more indicators if we are able to identify different dimensions. We normally have 5 steps in this analysis. First of all, we try to select indicators which are substantively meaningful and useful. Mostly we use really objective indicators. Rarely we use questions that are really subjective. The second step is identifying underlying dimensions. Using also an approach proposed, well, not proposed, but used by some colleagues in Ireland, Professor Whelan, Professor Nolan, and colleagues. We normally make a factor analysis in order to identifying dimensions within the data set. But sometimes we discover that maybe one item has been put in one dimension, but it has no meaning. So we really don't want to follow factor analysis at 100%. Sometimes enter also, you know, some sensible considerations, reasoning from the researcher. In fact, in the afternoon, I will show how the new dimensions have been constructed on the basis of the new SILC, the Statistics on Income and Living Condition, the new survey that started some years ago in the 27 European countries. After that, we try to assign numerical values to ordered categories. What does it mean? Of course, when we ask, do you possess these durable good? Is your house or this item in good or not good condition, and so on? Or do you have the television or not? You may give simply 0 and 1. But sometimes in these surveys, questions are formulated so that you ask also why you don't have a particular durable good. For instance, if the person answers, no, I don't have the computer or the television, you ask why you don't have. Because you cannot afford, or because you really don't want it. In particular, in the former panel survey in Europe, the European Community Household Panel, there were many questions asking more, not only you possess or you have or you don't have. So I think it could be used also to solve the problems arised before, But if you decide that you don't want a television, you may be considered non-poor, or you may be considered partially poor. Of course, it is your lifestyle, but if you receive some friends and you don't have the television, maybe that evening you cannot watch the very important football match. So in some way you lack something, even if you have decided not to have the television. And so on. Or for instance, you live in the central part of London and you decide not to have the car. You are a rich person, you take the tube, or better, you take the cab, But sometimes, there is the cab strike or the tube strike, and you don't have your car. So from this point of view, probably you're not completely non-poor, and so on. So we may decide to give scores different from 0 and 1 from this point of view. After that, and this is a very important point, is weighting of measures. Because when we want to pull together items within one dimension, it is important to ask to ourselves, but is this item really important in this country, in this society? For instance, the example of before, television 40 years ago and television today. We propose a weighting system which takes into account the dispersion of a particular good, a particular item among the population. Of course, 40 years ago, television was not so important. Today it is important. If you don't have television because you cannot afford, probably you are poor compared to other people. So it is really a relative approach. So it is important how this item is distributed. But later we will see another important consideration. So once you have defined the scores and you have identified the weights for that item, you just simply calculate a weighted mean for the FTSE supplementary. Again, if you want to compare this measure to the FTSE monetary or to the traditional approach, you simply rescale using another alpha so that the mean of this FTSE supplementary is equal to the headcount ratio. Of course, this alpha is arbitrary, but it permits you to make comparisons. If you don't want to make a comparison with the traditional approach, you don't use these, and you just have a measure that itself doesn't make sense itself, but when you disaggregate this average among groups in the population, you can compare them. Okay, the construction of the weights. Kelly and Lemmy 95, and before them also Cerioli and Zani, just proposed a weight of an item is equal to the logarithm of 1 divided by the mean, so the diffusion of this item among the population. So this is something important, but later on we thought, well, but if in this methodology we consider 30, 40, 50 items because we have a very, very rich survey. And in the questions, there are two questions, so two items, which are highly correlated each other. Does it make sense? If I include the TV color, and I also include the remote controller, those two are highly correlated. But how much is the added value of using the remote controller as? So we try to incorporate correlations between among one item and all the others, and try to reduce the weight when an item is highly correlated with other items. So this is the final proposal of the second weight, because we want to distinguish between items which are lowly correlated and those who are highly correlated. Maybe I don't have time to explain why we. So now we have tried to solve the first problem. So just to define a membership function, a fuzzy monetary, fuzzy supplementary, and also many membership function for the many dimensions that we can discover. Of course, this is one of the methods. There can be many methods to define the membership function. So far, there is not much about fuzzy set theory. Fuzzy set theory can play a role when we want to put together the different dimensions. It could be the monetary dimension and the supplementary dimension as well, or the different dimensions that we have discovered we want to pull together. Or we are also interested in another dimension, the time dimension, because we can have a membership function in 2001, another in 2002, another in 2003, and so on. So we want to see to calculate the join membership function between 2 years, or among 3 years, 4 years, and so on. Of course, only if we have information for the same individual or family during many years, so a panel survey. We have considered just 3 type of operation. Mathematicians, people that are familiar with fuzzy set theory know very well these operation. For the moment, we just consider intersection and union, because probably are the most important operation. And we just use the standard operator, algebraic, and bounded, because are 3 cases where we can think about. In the algebraic, we put the first one in this base, and we put the second in the middle, so that the intersection is exactly A multiplied B. In the bounded, we put the two membership function in the opposite bases. So if the sum of the two is bigger than 1, then there is a positive intersection. Otherwise, the intersection is 0. How can we interpret, and which of these operator we want to use in poverty analysis? Let's think standard. Standard means that the two membership function refer to two sets which are positively correlated. The algebraic means that we are facing two sets which are probably independent. In fact, as you can see, this is the join membership function. Let's think about the probability. The probability of A and B, if the two are independent, is the probability of A by the probability of B. Of course, I really don't think that membership function is a probability, but just to explain this, when the two fuzzy sets are independent, so this is the appropriate operator. when the two sets are negatively correlated, so the bounded is the appropriate, because as you can see, you put in the opposite base. So for instance, if I want to calculate the membership function of being poor this year in the FTSE set of poor people this year, and in the FTSE set on non-poor people next year, which is a FTSE set in 2 dimensions, so I can put the membership function in the first period here, and in the second period here, because it's 1 minus that value. What we have proposed is a composite system. So when we make intersection of sets of the same type, we use the standard. So the same type means poor, so in monetary terms, and deprived, so in supplementary, with a multidimensional approach. Or non-poor and non-deprived. But when we want to make intersection of sets of the opposite side, so being poor but not deprived, and vice versa, of being poor this year and non-poor next year, we use the bounded. And so we make a combined operator. As you can see, the sum of the 4 membership functions is always equal to 1. And this is correct. If we take one period, I may have a degree of 0.3 to the FTSE subset of poor people, and of course 0.7 to the FTSE subset of non-poor people. If I consider 4, so the combination, the sum of the membership function should be equal to 1, and so on. So this is consistent with FTSE set theory. So let's consider how we can implement these ideas now very quickly. When we have only 2 dimensions, so monetary and non-monetary, we can define the manifest deprivation index and the latent deprivation index. The manifest is the intersection, so the minimum of the 2 values. And the latent is representing the individual being subject to at least one of the 2. So is the union, so the maximum of the 2. So for instance, if we observe income poverty and lifestyle deprivation, so FTSE monetary and FTSE supplementary, the intersection is manifest deprivation. Could be interpreted as the following. If we use only one of the 2 methods, this is the quantity of poverty or deprivation that we are able to discover. And the union is the quantity that we are able to discover if we use both methods. And it is the latent deprivation. So the minimum of the 2 is the manifest, and the maximum of the 2 is the latent. Here we can see this concept in a graph, but we don't have enough time. Now we can also use these composite set operations in longitudinal aspects. We can see just 2 periods. In persistent poverty could be seen as the minimum of the 2 values, so the FTSE monetary in year 1 and the FTSE monetary in year 2. But of course, here A and B could be any membership function, so FTSE supplementary or other dimensions, dimension 1, dimension 2, and so on. So dimensions that we have discovered, for instance, with factor analysis. Ever in poverty, so poverty at least one of the 2 years is the union, so the maximum, and never in poverty, of course, is 1 minus the maximum of the 2. So the intersection of being non-poor the first year and non-poor in the second year. This is, of course, in FTSE terms. And so on. We can construct a sort of measure of exiting from poverty, entering. And, of course, we can extend this analysis in 3 periods, 4 periods. We have applied to the 8 years using the data from the European Household Panel Survey. So, when you have many, many years, the anytime poverty is the maximum. So, being at least 1 year in poverty, and the continuous is the minimum. Of course, this method could be applied also to the traditional approach. If here the membership function is not a value between 0 and 1, but it is 0 or 1, exactly as in the traditional approach, this we can construct exactly the anytime poverty and the continuous poverty. And of course we can also construct persistent poverty. For instance, Eurostat defines a person or a family persistently poor, not if the family is poor in every year of the period considered, but if it is poor at least in a majority of the T years under consideration. So, for instance, for 8 years, if you are poor 5, 6, 7, and of course 8, you are considered persistent poor. This is the Eurostat definition. Okay. I wanted to say another thing, but probably I will say in the afternoon with the results on real data. So thank you very much for your attention. Well, I think that this method really was born to be studied at individual level. Person, household, not at aggregate level. So in any panel survey, of course, you have the problem of attrition. So people that are followed the first, the second, the third year, and after that they leave the survey. Of course, in this case, if the analysis is wanted to be for 8 years, you have to consider the so-called balanced panel. So consider only units that are observed in every year. Of course, this is, but this is true also in the traditional approach. I mean, this is, I think, yes, I think another problem. And FTSE set theory doesn't solve this problem, you know, of attrition at all. Yes, in the data. If you don't have enough data, of course, you may, if you have, well, here we may distinguish between attrition, unit no response, and item no response. So attrition means that you follow a person or a family, and after some years, this family doesn't respond anymore. So you lose these, and you cannot impute this information. When you have, for instance, a unit no response only for 1 year, so for instance you are able to interview a family for 4 years, but 1 year the family does want to collaborate, but after that you are able to interview again. This is a unit no response. You may try to impute, for instance, income using information from the previous year or from the following years. Sometimes you are able to interview the family, but maybe the family doesn't respond to 1 or 2 questions concerning, presence of durable goods. So again, you can try to impute this missing value, if the missing values are not too many. Yeah, we saw 2 days ago, the distribution of missing values in the 13 items in the Brazilian data set, and so in that case there are there are some families with just 1 or 2 missings. In that case, instead of throw away the unit, it's better to impute with the statistical techniques. Yeah.
Okay. You want me to? People keep asking me how to combine various dimensions when you have many dimensions, and I was interested in your comment to say when two variables were highly correlated, you should reduce the weight, which actually seemed quite the opposite to my instinct. When one of the variables is income, this is my argument, saying we have all these dimensions, but we don't, a priori, we don't know how we should weight these, or whether they're an indicator of poverty or not. We're agnostic with the data set. The one thing the gut instinct tells us is poverty is, on the whole, should be related to income. In other words, as income goes up, it's less likely that someone's going to be poor. It's about the only dimension of which we're sure about. I mean, if health goes up, or if whatever it is, whatever activity that is being recorded, we may have doubts about these other things, but the one thing we're pretty sure about. Okay, so let's take that as our sensible start to say, however we want to combine these, we want to give a serious weight to the income variable. Now suppose we have another variable, and we know that let's suppose it's not very highly income correlated. You know, it's sort of, let's just say, I'm not quite sure, how many sugars you take in your tea, for example. All right, we measure this, and it doesn't have a correlation with the income dimension. Something else, let's take reported health status, is correlated. Now, according to you, we should give less weight to income and the number of sugars in your tea. You should give more weight to those and less weight to the health versus income correlation. And it strikes me as being totally the opposite to my gut instinct, which is to say I should be giving more weight to the fact that I've now discovered that the self-assessed health status is correlated with income. That's more of an indicator to me that it's important in determining poverty, and the fact that the number of sugars I have in my tea isn't correlated is telling me I should give that less weight. And I'd be quite interested, because this is exactly the opposite advice I give to people when they're asking me this question.
Yes, but I completely agree. In fact, we really think that income should not be included as a variable in the so-called supplementary variables. We really believe that income or expenditure consumption is fundamental. So we always put in another side. It is a very important dimension, so we don't weight income. We calculate one membership function, separate for income, and one or many other membership functions for the other one. For the number of spoons of sugar, we try to eliminate these kind of variables by reasoning. When I said that we have to try to include objective variables, I meant exactly these. The researcher should avoid to include in the set variables that are not really sensible in these analyses. Of course, otherwise, if you put something which is completely not correlated with poverty, of course, this item could receive a very high weight, but it is nonsense. So I think that we should make a sort of screening before including items in the analysis. But sometimes you include 2 or 3 items which maybe are important, but they are highly correlated. And this depends very much on the data set, because sometimes a survey give more importance or weight or questions to a certain dimension. Why do you want to include 7 items and questions in one dimension and maybe only 3. This is because people who influenced the construction of the questionnaire, were people that were more interested, for instance, in health, compared to people that were interested in information on the labor or housing condition and so on. So in order to try to avoid to give too much weight to one dimension compared to the others, of course, within one dimension there are items that are highly correlated. So if you have 2 or 3, or if you have 10, it makes difference. So if you have 10, you try to reduce the weight of these items in order to give a reasonable weight to that dimension. But I would exclude the inclusion of a number of spoons in the tea, because of course from the data you can get a very high weight, but it is nonsense. I agree with you. I don't know if I have answered properly to your question, or completely, or partially, Or
Well, let me just comment on that then. I'm really worried about giving too much discretion to people. I think the whole point is we should be giving advice to people, and that advice shouldn't be to say, look at the data and throw out the variables you don't like, because
well, but not because I don't like, because you said.
Well, I used the idea about sugars in your tea as being an extreme example of one where we don't think it has any relationship to poverty. But in lots of other cases, we don't know a priori whether this is a poverty indicator. That's what we're trying to get the data to tell us. We're trying to get it and to say, this is what I'd rather give someone advice as to what to do. Now, I understand the problem of saying, in some data sets we have a lot of correlated things because whoever's designed the questionnaire has a particular interest in this, and we're getting lots of different ways of measuring or capturing the same sort of thing. But this is what statistical analysis is about. I mean, it is to try to take this data and extract the essence. So, and I'm not enough of an expert to say how that should be done, but I was just picking up on the fact that your recommendation went against my gut instinct, and I appreciate now to say, okay, income is so clearly separate that we're going to take it out and not to bother. But again, I don't know. I'm not altogether happy with that, because then there might be other variables which could also be, say, we're taking out income, but we're also taking out health because we think that's an important poverty indicator. And so, how many things do you take out? What advice do you actually give to a researcher that's turning up and say, here's my data set, what do I do now? Do you really just say, you sit down there and use your, be sensible about this? I just feel that one should give rather clearer cut instructions and, procedures that ought to be followed, rather than to give a lot of discretion to people, because that discretion can really influence the way that, it allows people to do some analysis. They get a result they don't like, they go back and throw out some more variables until they get the result which they like. And I think that's not what we should be recommending for people to do, either as statisticians or as economists.
Yes, one way that we may avoid to use these correlations is the following. You make a factor analysis, you discover dimensions. Maybe you see that some item has been assigned to a wrong dimension from a poverty point of view, so you change, you move one item from one dimension to another. You try to make a confirmatory factor analysis, and if you see that this is reasonable, you take those dimensions, and at the end of the day, you give the same weight to each dimension. So you don't take into account those weights based on correlations. And after that, when you have 4, 5, 6, 7 dimensions, you combine them using fuzzy set theory. In the afternoon, I will show you what we did in the second report on income and social exclusion. So where 5 dimensions were identified, and also what we have done right now with the new EU-SILC data, where from the data, now there are 27 countries, and some of them are really different, the new member states, and also Romania, Bulgaria, and so on. So there are really information from countries with a different background. And we have identified 7 dimensions, but here we have also included the health dimension, so taking information at personal level also. And we have seen that 2 or 3 items were assigned to wrong dimensions in our opinion. So we just moved to another one, and we made confirmatory factor analysis, and we got very good results. So maybe this could be a practical method to be used, and once you have identified dimensions, it's done. You play with a fuzzy set if you want to discover, if a unit is poor in every one of these dimensions, or in at least one, or in 3 out of 7, and so on, or in none of them. So you can calculate all the possible membership functions.
But now Professor Betti will talk about applications to Europe.
Thank you very much. So it will be, I hope, a very quick presentation. I can skip quickly this part I have already presented this morning. So we can start actually with the dimensions that we identified in the second European report on poverty, income and social exclusion. So in the Eurostat report that I brought here a copy, but you can download from the Eurostat website. Here through factor analysis where dimensions were identified. In the first dimension, termed by Eurostat as basic lifestyle deprivation, there were how many? 7 items, so 7 questions from the ECHP questionnaire, so European Community Household Panel questionnaire. So they were keeping the home adequately warm, paying for a week's annual holiday away from home, replacing any worn-out furniture, and so on. The second dimension was discovered as secondary lifestyle deprivation. So having a car or van, color TV, video recorder, microwave, dishwasher, telephone. And again, as I said to you before, in the questionnaire was asked, do you have this item? Do you possess this good? And if the answer was no, it was asked why. Because a person couldn't afford to buy a car, or if this person really didn't want, because it was living in a metropolitan area where is not really needed, and so on. The third dimension was housing facilities, so having a bath or shower, indoor flushing toilet, hot running water. The fourth dimension was housing deterioration. So leaky roof, damp walls, floors, foundation, rot in window frames or floors. And the last one termed as environmental problems. So shortage of space outside the house, noise from neighbors or outside, too dark, not enough light, and so on. Pollution, grime, and vandalism or crime in the area. Eurostat decided not to include information about health at that time. but we really think that since these information are present in the survey, also in the new survey, in the new European Union SILC, Statistics on Income and Living Condition, we have tried to reperform this factor analysis on the new data set. So for the moment, I just keep this presentation and I go to the 23-24 items that we are working in. We are working with in the new EU SILC. We have performed a explanatory factor analysis, and by the data, the analysis has identified 7 dimensions, as I told you before. But you know, having a look of these data, of course we don't like very much that car and PC go in the first dimension, the primary lifestyle dimension, and also inability to cope with unexpected expenses. So we have thought a little bit, and we have tried to rearrange these indicators, these items. For instance, we have put inability. Oh, okay. Inability to cope with unexpected expenses into dimension 5, so arrears. And we have moved car and PC in dimension 6, so with telephone, washing machine and TV. And also we have merged having bath or shower and indoor flushing toilet to leaking roof and damp and rooms too dark. What we have done, we have rearranged these and we have performed confirmatory factor analysis. And this regrouping was good. So what we want to do, we want to propose to Eurostat this new grouping. And as you can see, there is a new dimension, so the health dimension, where we have put general health, chronic illness and mobility restriction, which was not present in the second report of 2002, only because Eurostat decided not to put this information in as a dimension in the analysis. So this just to go back to my morning presentation. We have tried, I have tried to do the same, to work with Brazilian data that I received, but for the moment probably I didn't work very well. I constructed the items not in a proper way. So I used only 13 items, I think, and we got only 3 dimensions, but we had a look and we didn't like them very much. So probably I have to work well. We have to work better to do that. So let's go back to the presentation. So these the 5 dimensions in the ECHP. Now I present just some figures, and I start with the traditional approach. In order to understand which is the situation in Europe, or better, which was the situation in Europe in the second part of the 90s. Because now I'm talking about the European Community Household Panel, so a survey collecting information from 1994 until 2001. So income was referred to the previous year. So we are talking of income distribution from 93 until 2000. This is the situation in Europe when we calculate one unique poverty line at European level. So we pull together all the information. Of course, we rescale the weights so that the weights are representative of the European situation. So we lower very much the weights of Luxembourg, and we increase the weights of Germany so that they are representative of the real population. Here we can see that the three worst countries in terms of percentage of poor people are Portugal, Spain and Greece, and after that Italy, UK and Ireland. Of course, UK is in absolute terms is a richer country compared to Italy, but probably there is more inequality. So if you define a poverty line in a relative way, the percentage from the ECHP was around 20%. So very close to the upper limit that you talked about this morning, you know. When you use the country poverty line, now the three worst countries are Portugal, Italy, and Greece. Because but look at this, is very interesting. When you go to calculate a poverty line at NUTS 1 level, NUTS classification is a classification of regions in Europe. NUTS 1 are normally macro regions of a size of about 5 million. For instance, in Italy there are 11 NUTS 1 regions, and NUTS 2 classification is a classification that defines a region of a size of about 2 million, 1.5 million until 3 million. In Italy there are about 20 NUTS 2 regions, and so on. Well, at NUTS 1, it means that for every region you calculate a poverty line. So the reference is not the Europe, is not the country, is the region where you live. And for instance, here it's very strange that the percentage of poor people in Britain is higher than Italy. Because in Italy there is regions are very heterogeneous, but within, so there are very poor regions in the south and let's say richer regions in the north. But when you refer, you take for instance Sicily, and you refer, there is not much inequality within those regions. In UK, regions are very similar, but inside every region you still have the same inequality that you had in the country. Okay, so that's why the percentage is higher. But of course, the black, well, the darker value is between 17.7 and 21. But this is an interesting analysis. You know, when you have a relative poverty line, it is important to understand to what you are relatively poor. You know, to Europe standard, to the country standard, to the region standard, or to the the province where you live. And this is important to understand things, and also to compare, to be able to compare results with the FATSI set analysis, and also to the supplementary analysis. Okay, here I have reported the distribution of poverty rates for some selective countries. Here there are the results, the cross-sectional results of the totally FTSE and relative monetary poverty. Of course, at national level, there is no difference, because with the alpha that I have explained this morning, the mean of the monetary index, so the membership function, is exactly equal to the percentage of poor people. So what is interesting is when we disaggregate the population in regions or in groups of individuals or families. So by family size, by sex, age categories, by labor status, and so on. So in that case, it is interesting to compare the results between the FTSE approach and the traditional approach. Now we have, so far we have talked about monetary poverty, but let's have a look of, the richness or welfare. Here I have reported the net equivalent income at regional level in logarithm terms, because we have modeled this variable, but of course it doesn't change if I would have put the real net equivalent income. Here we can see that, of course, Britain has much clearer colors. So in absolute terms is richer than Italy and then other southern European regions. From this point of view, the poorest regions are in Portugal, Spain, southern part of Italy, which is very similar to, Eastern European countries. Now I have added also the new member states. This is EU 27. We have Romania, we have Hungary, we have the three Baltic countries, and so on. The richest areas are, of course, London, Paris, and many of landers in Germany and Denmark. Here I have talked about equivalent income. Also this morning Professor Shorrocks talked about the difference of total disposable household income and on the other side the per capita income. So the equivalent income is the total income divided by the equivalence scale. So how much is the weight of a family of two people, in order to reach the same welfare level of a single 2, 1, or something between 1 and 2, so 1.5, 1.6, 1.7 times. So this is the concept of the equivalence scale. What I have done, just to show you that, in the traditional approach, the headcount ratio is very sensitive to the choice of the equivalence scale. I have performed a sensitivity analysis. When we talk about equivalence scales, there is a parameter called elasticity, which represents, how much do we have to increase the needs of a household when a new member comes into the household. So the elasticity can vary from 0 to 1. So it is 0 when, every new individual in the household, when a new individual comes and no more needs, no more resources are needed for getting exactly the same utility level, exactly the same welfare. So in that case, the variable that we use is the total household disposable income. On the other side, when elasticity is equal to 1, means that every added individual that we have, we need to multiply the resources that we need. So it means it corresponds to the per capita income. And every value of the elasticity between 0 and 1 correspond to different economies of scale. So what I have done, I have chosen a model. I don't explain the model at the moment, where it's possible to vary this parameter. So I have reported here 100 different values of this parameter, and on the basis of this parameter I have calculated the equivalence scale, and with this equivalence scale I have calculated the equivalent income, and I have calculated the percentage of poor individuals according to this variable. And as you can see, with this data, percentage varies from 26% until 22%, with a minimum here of I think 19%. So as you can see, the headcount ratio is very, very sensitive to the choice of the equivalence scale. And in particular, in Europe, the scales that are normally used, the OECD scale, the OECD modified scale, normally have a elasticity that ranges between 0.6, 0.7. So, if by choice you by definition you choose the per capita income instead of the equivalent income, you by definition have a higher poverty rate. Of course, one could choose exactly the equivalent scale so that you minimize your percentage of poor people, But anyway, so it is interesting to have a look at what it happens when you change one parameter like this, which is very important to me. So there are in the literature there are really hundreds or thousands of papers concerning equivalent scales. I can give you a literature review. So going back to the presentation. Let's have a look of the FTSE supplementary disaggregated at NUTS1 level region. Here you can see that even with the supplementary approach, the worst regions are in the Portugal, Spain, Italy, and Greece. So in fact there is a correlation between FTSE monetary poverty and FTSE supplementary poverty. But when we want to observe different dimensions, we discover something very interesting. For instance, we saw dimension 5, environmental problems. Normally this dimension is negatively correlated with income, so with a monetary indicator. As you can see here, the region of Madrid, the region of Barcelona, okay, here we cannot distinguish very much because there are not too many. There are just 2 NUTS1 regions in Portugal. But Lisbon and Porto and Paris and Rome and Naples and even a little bit London, are, from this point of view, are in a worse situation compared to other regions, like Finland. Yeah. So it was a very good choice, Helsinki. So no crime, no pollution, no. You have a lot of area. So Denmark is very good. I think also Essex, Colchester, is not a bad area, but there are around London, and I think here is Birmingham, Manchester, Newcastle, and southern part of Italy, crime, mafia and so on, and pollution, maybe now it's even worse with these problems of garbage and so on. So this was interesting, and if we go further, so we disaggregate at NUTS2 level, we can even see better these problems, This is really Porto and Lisbon, Madrid, Turin, Milan, Rome, Naples, Paris, London. Before this area, it was the southeast was not so bad, but now here London is really black, and also here I think there are Birmingham and Manchester. Unfortunately, we don't have enough information from Germany, because I really believe that in some areas, industrial areas in Germany, you may have some problems, even if they, are very, very rich areas in terms of income. But here probably data from Poland are not really comparable with the rest of Europe, because at that time Poland was not in the Union, and so they did not participate into the European Community Household Panel Survey. So here there is something very interesting. This is the degree of intersection. This is the ratio manifest divided by latent. As you can see, the richest countries have a smaller degree of intersection between FTSE monetary and FTSE supplementary. So that's why we really think that the use of FTSE set theory is important in more developed countries, in richer countries. For instance, if you had a very, very poor country, probably the overlap is 90%, 80%. If you go in a very, very poor country, I don't know, in Africa, you can use any method you want. You always discover that there are many, many poor people. Okay, you don't need very sophisticated measurements. You only have to act, to do something to combat. But for instance, when you go in rich Western European countries, maybe you discover that there is something like that. That the intersection is very small. So if you focus only on monetary deprivation, you don't see everything. So it is important to analyze many different dimensions. And this is clear. In Sweden, Finland, Denmark, the intersection is very, very small. In poor countries, Portugal, Greece, Italy, Spain, the intersection is much larger. So this is another point. And the last point is when we study poverty dynamics. With the FTSE measures, we do not overestimate transitory poverty, transient poverty. And we do not underestimate chronic poverty, as it is done with the traditional approach. So this is another important result, and so this method could be used within the traditional method. So you can learn more. Well, I think that's all. So it was half an hour, so we can have some space for the other presentations. Yeah. Well, I already showed these results a couple of days ago, so for some of you it's just a repetition, yeah. But yeah, thank you very much.
This work I did with Renata. She was my professor, and that's why we applied a fuzzy methodology. And this kind of research makes sense only if we compare rural and urban areas, because Brazil is very big and we have a lot of different inside Brazil. It's maybe some points here doesn't make sense for Europe, but for Brazil, yes. That's why. Okay, and another point, this paper is based on another study from IPEA, from PB and Rosani that was here in the morning, and then they calculate not with fuzzy, but another index, poverty index, with 5 dimensions. So one dimension was household conditions, and some results that they compare rural and urban areas, for me was a little bit not strange, but I think doesn't it's not our reality. That's why I try to use another methodology to calculate that. So as I told you, I base it on Barros et al. Work, but they were based on another work from Sen and Anand that calls poverty index, that was based on Human Development Index. That was the beginning of this this discussion. And PB, Barros, PB, that how we called him here in Brazil, he tried to put more, to aggregate more variables, because the poverty index from Sen, he's trying to compare different countries, and of course it's not that easy to compare different countries with a lot of variables, especially because they're not available. So that's why one of the reasons they did just a sum. So for Brazil, he chose not 4, but 48 variables in 5 dimensions. Okay, this is, I just talk a little bit about this poverty index from Anand and Sen. And okay, and let's go to PB methodology. So he got 6 dimensions, and one of these dimensions that it's household conditions. He said carências habitacionais, but it's not really carências, because some households have many things, so they are not. So that's why I changed it a little bit for just characteristics from these households. And also in Brazil, we usually calculate for households, not families, because it's very often in some rural areas or some poor areas. In a household, they have a lot of families. So it makes sense if we analyze the households, not the families. And okay, so in his methodology, he had, as I said, 6 dimensions, 26 components, and from these 26 components, he has 48 variables, and with that, they calculate the poverty line, the general poverty line. From this, especially for the households, they choose, this is property for the household, the density is the relation between rooms and how many people live there. The water system, the sewage system, the trash collection, electricity, and durable goods. So now I'm going to talk a little bit about the weight. So in his methodology, each dimension has 1, 6. This is the weight for each one, and for each one, it have, for example, if have 5 components, they divide 1, 6, 4, 5. It was 3 components, and so on till the end. So in our case, that is household conditions, it was 1 plus 6 divided per 8. Okay, so this is the variables that they chose. So the first one is property of the house. In this case, Renata and I, we chose not consider this variable, especially because in rural areas, in rural areas and small properties, they don't get the property of the house. This is a law legislation problem here in Brazil. So if you have the property or not, it doesn't mean that you are poor or not. So we decided to take out this variable because it's maybe it's overestimate our index. The second one is the density, and they choose 2 or more people for each dorm room. So we considered that, and we made a little different that I will explain after that. And also we could see how this house is built. So the cover of the house and how do I say? Walls. Yes. Okay. And the walls. That was okay. Also, we take it. And the water sewage, it's okay. And about the trash collection, in case of Brazil, it's a little bit difficult to consider trash collection in rural areas because this is a public service and it's not that easy to get there, and also because it's not that important to take this trash in rural areas. So in the beginning we decided to take out, but the problem is at IPEA where I work, we received some critics that, oh no, this is very important, you should take it, so you shouldn't take it. So we decided to bring that back and we calculate together. But anyways, I think it's a little bit problematic to stay with that variable. The other one is the electricity, and here Renata and I we distinguish a little bit electric and the other possibilities that we have light at home. Yes, of course, also because energy is one service that is comes from the government, and many, especially rural areas, we just don't have that. But we have another possibilities that we can get from this, from PNAD, our survey. And the last one is durable goods, and in the beginning they put often refrigerator, TV, radio, telephone, and computer. It was, I asked you today in the morning about computer because if we don't have energy, we are sure that we don't have internet and so on in rural areas in Brazil, as well as telephone. So it's it doesn't happen at all in Europe. Every country that you go, you can take your cell phone. It works, but in Brazil, no way. It doesn't happen, even from one state to the other. So I'm going to explain why I took out telephone and computer. I stayed without. So what I did here was just to make sure that it was correct what I was thinking about telephone and computer, and I decided to make a very high line according to our minimum salary. But this is I calculate for per capita income, and my per capita income was this minimum salary. So this is for us very, very high. And this is below, equal, or above. So what I got, this is for 2006, so for 2 years ago, that telephone in rural areas, who has telephone was with low per capita income was just 10%, and if they have high per capita income, it was only 20%. So it's not too much people had telephone in rural areas. And in urban areas, even in urban areas, we don't see like a big difference between one and the other. So because my analysis, my comparison is between rural areas and urban areas, I decided to take it out. I think this is not representative for what I would like to do. The other one is computer. It's almost the same. Who has high per capita income? The households, they also have no computers, and I think that we can explain that with the same reason that they have they don't have many kinds of service as electricity and so on. So how did I get the weights? So in this, how do I say that? Purple is the PB methodology, and the other one was I proposed by Fuzzy. So PB said that he would like to calculate the density of a household for 2 or more people per dorm rooms. And we choose between 2 and 4. If this relation is under 2, they are no poor at all, and if they are more than 4, they are very poor. I mean, with our research, with our survey, it's not possible to know how big or it's one household. So maybe it's 4 dorm rooms, but these 4 dorm rooms are very small if we compare to another house. So unfortunately, this kind of result it's not possible to calculate. The other one is the cover and the walls material. So we have durable and non-durable, and what I did was like a matrix, and if they're durable and durable, they are not poor, and even the one of those are not durable, I choose 0.5, and if both are non-durable, I said that yes, they are really poor. So the water and the sewage in Brazil is two variables a little bit problematic to calculate because they have a lot of missings. So it's not what I would like to do, but what I could do according to our survey. So the first one was water, and PB said just the inappropriate water. We decided in the beginning to divide piped water, well water, that water from the from the source, source, yes, from the source. But this kind of variable was very, the missing was more than 50%, so it's not representative, and we decided to take it out. So in the end, we stayed just with piped water in at least one room. What we added in this analysis was filtered water that I'm not sure how is all countries in Europe, but for example, Germany, I know that you can drink the water from your kitchen without filter. Yes, here in Brazil, we recommend you don't do that for many reasons. So that's why we added this kind of filter water, and we did or we construct the same metrics as before with 1, 0, 1, and 0.5, 0.5. The other variable is sewage system. We choose also three possibilities, three weights. So if you have like a regular sewage system, you are not poor. I don't know how to. Can I translate fossa septica? I'm sorry. This is. Yeah, this is like a house outside. It's like a room outside your house that we make a hole, and they go to like a bathroom. I'm sorry, I don't know how to say that here in Portuguese, in English. Yeah, okay. Septic toilet. Okay. Yeah, okay. So why we decided to do that? Because this is the most important problem that we have in Brazil, even for urban areas. And the third option is lagoon and ocean, river, and so on that have nothing. They just go there. So it's the third option that we say, yes, they are really poor. About trash collection, PB has just to say, yes, they have the directed collection or not, but we decided to put it in this analysis. Of course, we don't like too much this kind of variable, but anyways, we did with indirect collection or burned. Okay, yeah, burned trash because of course we have many areas we don't have this kind of service, and they just burn it there. This is very common in Brazil, so that's why we put this kind of option too, and this is the. We didn't say electric light because not all options are from energy, but also from the sun, from the, how do I say that, generator? And oil, kerosene and gas. So we also made some different options according to our reality in Brazil. So, and the durable goods that I'm sure that we will change a little bit in the future. But anyways, we took out telephone and computer. We stayed with the often refrigerator, TV, and radio, and we aggregate a little bit. For example, refrigerator for 1 or 2 doors because it's not that important for us. Just if they have or not. TV, we still have in Brazil a lot of black and white TV, and so we decided just to put together a color TV or black and white TV. And I think from all 4, the radio is the most popular one and the cheapest one. Maybe thinking now about what we were discussing today in the morning. The relation between maybe radio, it's that cheap that it's not really a good indicator for poverty because everyone could buy. If someone doesn't have radio, maybe it's because they don't want to, not because they are poor. So That's what maybe we could change a little bit in the future. So our methodology was that we did. It was according one work from Lemmy, but we didn't calculate the correlation. That maybe will be also another proposal of us. We did two different ways to calculate this index. The first one was one index for each variable or each indicator from that. And another one was to calculate the index for the whole dimension, and we compare the rural and urban areas. This result, we know that is not the best one, because we are just consider one dimension. And our proposal is in the future to add the other dimensions. But this dimension is the dimension that we have more problems to compare rural and urban areas in Brazil. That's why we start with this one. Maybe income too in the future, but anyways, we didn't add income here. So our results, the first ones, as I said, was to the index from each indicator. So density, water, and so on. And okay, so the best, we identified that the best index for almost all of them was energy, or how do I say energy, right? Even for rural areas, but we are sure that it happens because we consider also the another possibilities that is not electric light. Except this one, but I'm not sure that maybe this kind of result for household material is not that. I don't know. I think this is not that correct. And so, and the worst one for also rural in 1996 was water. After that was solid system. So and for our reality, it explains a lot, and I think this makes sense for us, because we know that even with some investments, this is something that our government have to do more. If we see here was 0.47 and was worst 10 years later. In the beginning, we was thinking about and said, "Oh, I think make no sense, because even when something if a government make an investment, this investment will be there. So how you can change that with more than 10 points?" But the problem is during this time we have a lot of agrarian reform in Brazil. And when these families bring or get the first piece of land, they have nothing there. So before it was like nothing; it was like a forest or a old farm. And from one day to the other, we have 1,000 families, 2,000 families, and they count as a household. So it is one. Possibility to explain why it's worse sewage system in rural areas between these 10 years. And the other index that I calculate was the total one from this dimension. And what was, okay, we can see that rural is more poor than the urban areas. It was for sure. We were sure before we start this work. But what was interesting for us is that the urban areas had, in this dimension, was getting the best results between 10 years than the urban areas. So this is okay, and this is this. I'm not included here the North Brazil, Amazon, and so on, because they have no database for 1996. But anyways, I think this is a good result, and maybe it's not that good according to this kind of politic, but agrarian reform. But it doesn't mean that that we shouldn't do agrarian reform. But we need a little bit time to take or to give this kind of service to these people. It's not from 1 year to the other. So I think I just put some conclusions here. Some of them I already said. Yes, that's water and sewage was that should be the system that need more investment from our policymakers, especially because they have a lot of they are related to the health conditions. If you have bad water, you will be sick. So, and this is one of our big problems. If we have if we don't collect our sewage, it's always a problem, because if someone is sick, the other ones could be sick too. So water and sewage is both politics are more important for us, especially in poor areas. Yeah, electric, it was the best one. And yes, I didn't say, but almost all index from 1996 from 2006 was better, except that one. But I explained one reason that could be. Yes, and I think that's all. Our proposal is, of course, to do the other dimensions as PB did for Brazil, and to compare in the end to know how could be the results between these 10 years, maybe 1997 and 2007 already. And I think that's all. Yeah, I'm sorry, but I said that too. Yeah, I already said that. Okay.